Today we're going to be taking a look at law of sines, which is really just a formula. Now the law of sines and later on law of cosines in the next section is used to solve oblique triangles. So an oblique triangle is a triangle that doesn't have any right angles. So when we do have right angles, we can use things like SOHCAHTOA, we can use things like Pythagorean theorem, because those all are used for only right triangles. Now that we're dealing with oblique triangles, we're not going to be able to use our basic trigonometry like SOHCAHTOA, and we're also not going to be able to use the Pythagorean theorem anymore. So what we're going to be doing is we're going to be solving for triangles. We're going to be figuring out all three sides and all three angles of a triangle, but those triangles are going to be oblique. So we're going to be using today law of sines. Later on, we'll also be using law of cosines. So let's take a look at the formulas for law of sines. It's really just one formula, but here it's a ratio. So remember that the lowercase letters are sides and uppercase letters are angles. So this would be A over sine of A, so the side corresponding to the angle. Remember that sides and angles are always opposite of each other. And we would set it equal to B over sine of B or C over sine of C. And any of these can be put together. You only need two. So I could have A over sine A is equal to C over sine C. So we never use all three. You just choose two based on the information that you're given. You could also reciprocate. So you could also have the angle in the numerator and the side in the denominator, but then you'd have to do the same with the other fractions as well. So usually my suggestion is going to be that whatever side or angle, whatever it is that you're looking for, that's what should be in the numerator. All right, so if you're looking for a side, put your sides in the numerator. If you're looking for a missing angle, use this version. Use the angles in the numerator. And that's going to be the easiest way to solve, although either method really does work. All right, so let's take a look at example 1. So in example 1, we're going to be solving the triangle. So you have to know what that means. That means that we want to know all three sides and all three angles of a triangle. And this is the given information. So because that's uppercase, angle C is 102.3 degrees. Angle B is 28.7 degrees, and side B is 27.4. So I've made this little chart right here, and it's going to be helpful for you to do the same thing, but I have all my angles and all my sides, and I've already plugged in the given information. So now this helps me to see that all I need to find is angle A, and side C. So the easiest thing to start with right now is to solve for this angle, because we know that in a triangle, whether it's a right triangle or an oblique triangle, there's 180 degrees. So if I do 180 degrees minus 102.3 degrees minus 28.7 degrees, I'm going to get 49 degrees. All right, so I know already. I've already solved for one thing. I know that this is 49 degrees exactly. All right, so let's go ahead now and find the two sides that are left. Remember that we can't use things like Pythagorean theorem anymore. We don't even have enough information. Even if we could, we will get there, but just keep that in mind. Pythagorean theorem will not work because we don't have a right triangle. So let's go ahead and set up a law of sines ratio. So I'm going to go ahead and look for side A first. So because that's the unknown, the variable, I'm going to go ahead and put that in the numerator. I'm just going to label this step 1, step 2 for this problem. So I'm going to have A over sine of A. And now I have to decide, well, am I going to put it over B over sine of B or C over sine of B? Well, in an equation, there can only be one unknown, and this is what we don't know. I do have angle A. I could have just plugged it in right away. But what I want to do is I want to take a look and realize that I actually have what I would call a complete set. I have an angle and its side, so that fraction will have no variables, and this fraction will only have the numerator as a variable. So I'm going to set it up equal to B over sine of B. So let's go ahead and plug in what we do have. So we still don't know what the numerator is going to be, so side A, but I do know that this denominator is going to say sine of 49 degrees, right? That's my angle A, equal to side B is 27.4 and over sine of angle B, which is 28.7 degrees. So now I just need to solve for this this variable right here. So what I'm going to do is on both sides, I'm going to go ahead and multiply by sine 49 degrees. You can put that over 1 if you want, doesn't really matter. Sine of 49 degrees over 1. All right, so these are going to cancel. They're going to cross cancel. So I'm going to end up with A is equal to 27 divided by 4. So I'm going to go ahead and plug that into my calculator. Make sure that you are in degree mode because these angles are in degrees. So my calculator is in degree mode. So I'm going to do 27.4 divided by sine of 28.7. I'm going to press enter before I multiply by sine of 49. So times sine of 49 in the next step, and I get A is approximately 43.1. Alright, so I rounded that, which is fine. Usually rounding to the nearest tenth will be alright, and you can see that the rest of the work or the given information has also been rounded to the tenth, to 1 decimal point, so we can just do the same. Now, let's go ahead and find side C. So again, don't try to use Pythagorean theorem even though you do have two sides. A squared plus B squared is not going to equal C squared in this case. Alright, so let's go ahead and use law of sines one more time. So I'm going to do step 3 over here. I'm going to use the same set, the complete set that I did before. I actually don't want to use A and angle A because I've actually rounded this answer. So whenever I can avoid rounded answers, I'm going to. I want to use exact values over rounded values as much as possible. So this time I'm going to do C over sine of angle C, which is 102.3 degrees. I'm going to set that equal to the B's. So 27.4 over sine of 28.7 degrees. So I'm going to go ahead and multiply sine of 102.3 on both sides. Excuse me. So we're going to do 27.4 over sine of 28.7 times sine of 102.3. So I'm just going to go to my calculator. Sorry about that, the way that it looks. Looks a little bluish. So I'm going to do 27.4 divided by sine of 28.7. Press enter. And then I'll multiply by sine of 102.3. And I get C is approximately 55.7. These are all feet. And there we go. I have solved for all of the missing sides, so I've completely solved for the triangle.